Welcome to video lecture series on microcontrollers and applications. In this lecture, we will discuss architecture of 8051 microcontroller. Recap on the basics of microcontroller. In previous lecture, we discussed about basics of microcontroller, where we discussed about microprocessor and microcontroller definitions. Then we discussed microcontrollers evaluation, microcontroller types, real-time applications of microcontrollers. Coming to today's lecture learning outcomes, 8051 architecture and components, where we'll describe the core architecture and memory organization, I/O ports, and CPU functionalities within the 8051 microcontroller. Program memory versus data memory. Here we will analyze the distinct characteristics and usage patterns of program memory and data memory in the 8051. Data flow in execution. Explain how data is transferred and processed within the 8051 during instruction execution cycles. Then, before starting architecture of 8051 microcontroller, let us see important features of 8051 microcontroller. 8051 microcontroller is a 8-bit microcontroller. Here, this 8 bits represents its ALU size, all internal registers, and all instructions are designed to work with 8-bit numbers. That's why it is called as 8-bit microcontroller. It is having 16 address lines. As we know, the memory capability of every processor depends on its address lines. But the 8051 microcontroller follows Harvard architecture. Hence, it can able to address 64 KB of external code memory, 64 KB of data memory. The operating voltage required for 8051 microcontroller is 5 volts DC, and the clock frequency is 1 megahertz to 40 megahertz. In some special application for serial communication, we'll use this odd frequency, that is 11.0592 megahertz. In addition to external memory capability, it is also having some internal memory, that is 4 kilobytes of ROM, which is used for program memory, and 128 bytes of RAM, which is used for data memory. In addition to this, it is having 4 resources. There are 4 I/O ports. Each port is having 8 I/O lines. So total it is having 32 I/O lines. The second resource is 2 16-bit registers, and they are used for generating the delays as well as for counting external events. The third resource in the 8051 microcontroller is serial communication port. With the help of this port, the 8051 microcontroller can interact with any other device serially. Last one is fourth resource is the 6 interrupt sources. With the help of these 6 interrupt sources, the 8051 microcontrollers serve 6 different sources or devices. So these are the important features of 8051 microcontroller. Then coming to our next, let us see one simple question here. What is the external memory capability of 8051 microcontroller? So already we know that the 8051 microcontroller supports 16 address lines. Whenever any processor is supporting 16 have 16 address lines, then its memory capability is 2 power 16. 2 power 16 is nothing but 64 kilobytes. So, and in addition to this, the microcontrollers or microprocessor support the two different memory architectures. They are named as von Neumann architecture. Another one is the Harvard architecture. So the 8051 microcontroller follows the Harvard architecture. In Harvard architecture, the microcontroller treats memory units as separate units for data as well as code, and it is also providing separate buses. So that's why the 8051 microcontroller supports 64 kilobytes of program memory, 64 kilobytes of data memory. You can see here the 8051 microcontroller support Harvard architecture. Hence, it can support 64 KB of program memory, 64 KB of data memory. Coming to the architecture actually represents the internal logic diagram. So already we know that from the definition of the microcontroller, it is an integrated circuit which includes entire system on the single IC. Okay, so let us see now what are the blocks are available within this architecture. So if you observe here, this is arithmetic logic unit. This is PSW, program status word. Then we are also having one A register. It is also called as accumulator, B register, and program counter, DPTR, data pointer, and some special function registers, and internal RAM of 128 bytes, ROM of 4 kilobytes, and there are 4 latches are there for latching the ports information here. So there are 4 ports are available as mentioned earlier. Port 0, port 1, port 2, port 3. In addition to this, we are having system, timing, system interrupts, timers, data buffers, memory controller. This is a system timing and control block. And this is expanded view of this special function registers and 128 bytes of RAM. Now let us see discuss arithmetic logic unit, ALU. Already we know that this 8051 microcontroller is a 8-bit microcontroller. That means its ALU size is 8 bits, all internal registers are of 8 bits, and all instructions are designed to work with 8-bit numbers. So that's why the 8051 ALU size is 8 bits here. This ALU will perform arithmetic and logical operations on 8-bit numbers only. It will perform arithmetic and logical operations on 8-bit numbers. And always it will take two operands. One is directly from accumulator, that is A register. The another number is taking from either B register or a immediate number, or it may be coming through memory. Okay, so that means the second source operand for arithmetic logic unit is the either it is coming from a register or a immediate number, or it is coming from memory. So that means the ALU will take two operands and it will perform corresponding operation, and the result is written back to accumulator only. The result is written back to accumulator only. And in addition to this, after any arithmetic or logical operations, if any conditions are generated which are stored in a register, that register is called as flag register or a PSW. PSW stands for here program status word. That means if any condition is produced, let us consider after addition there is a carry, after subtraction there is a borrow, and if there is a overflow condition is occurred, if there is a parity is generated. So that type of conditions are stored within the PSW. So from this I can conclude that arithmetic logic unit takes the two inputs. One is from accumulator, another one is from through a register, any register available in 8051 microcontroller, any 8-bit register, or immediate number, it may be immediate number, or any 8-bit data from the memory location, either from ROM or RAM. And after execution of this corresponding operation, the result is written back to accumulator. So after this, if any conditions are produced, that conditions are stored within the PSW. This is the operation of arithmetic logic unit in 8051 microcontroller. Then we do accumulator, a register. It is a temporary register, temporary storage register. It can hold 8-bit information, and it is acting as a source and destination operand for all operations, most of the operations, and most of the time the result is stored in the accumulator only. So that's why this A register is called as accumulator. It accumulates the result after execution of every operation. The result is accumulated in A register. So that's why it is called as accumulator. In addition to this, if you want to send any data to outside world, it should be from accumulator only. And if you want to receive any data from the outside world, the destination is accumulator only. So that's why the A register is called as accumulator. Then B register. B register is a temporary 8-bit register, and it can hold 8-bit information. In addition to this, it is also acting as a source for arithmetic and logical operations. In addition to this, this is also used as a source and destination operand for multiplication and division instructions. Multiplication and division instructions. Coming to PC. PC stands for here program counter. It is a 16-bit register, and this 16-bit register is used to point the address of the next instruction. The function of PC is it is always used to point to the address of the next instruction. So, and the size of actually, as I mentioned earlier, 8-bit microcontroller have all internal registers are of 8-bit wide, but this program counter is a 16-bit register. Why? Because actually the 8051 supports 16 address lines. 16 address lines means it can able to address 64 kilobytes of memory. So that's where the memory capability is 64 kilobytes. That means 16 address lines are required to access the program memory. But internally it is having only 4 KB. But the actual capability is here, if you observe here, A18, A0 to A7 here, A8 to A15. So that means it has to generate 16-bit address. So that's where the program counter is 16 bits here in 8051 microcontroller. And one of the most important thing we need to observe, in 8051 microcontroller, every register is having their own address, but PC does not have any address. Why? Because it is always pointing to the address of the next instruction. To execute your program sequentially, it is always points to the address of the next instruction. This is the function of PC. And one more important thing, it does not have any address. And coming to Next register, that is DPTR. DPTR stands for data pointer. It is also 16-bit register. This is also 16-bit register. Why? Because it is also pointing to the data memory. So as I mentioned earlier, the 8051 microcontroller supports Harvard architecture. Because of Harvard architecture, the external memory capability is 64 KB of program memory, 64 KB of data memory. To point this data memory, we require again 16 addresses, 16-bit address. So that's why the DPTR size is also 16-bit. That's why this bus is also represented with 16-bit address bus. And one more important thing, most of the cases we can this DPTR is divided into two registers. Why? Because it is a 8-bit structure. So the DPTR is divided into two 8-bit registers. They are named as DPTR high byte and DPTR low byte, DPH and DPL. And coming to this PSW, PSW we will discuss in next slide. Then first we'll see the RAM. The 8051 microcontroller is having 128 bytes of RAM. This RAM is normally used to store data of your application or user inputs of your application. And the expanded view of this one is, you can see here, the internal RAM is divided into three groups here. First group is register banks. These are the banks. And second group is the bit or byte addressable locations. And third group is the general purpose register, general purpose RAM area. And these are from 00H to 7F locations in hexadecimal. And here we are using only 7-bit address. Actually, to represent this RAM addresses, we are normally used require only 7-bit address, but normally it is a 8-bit register. We are having one more bit. So that's why the remaining address space, 128 space, is utilized for some special function registers. So there are several special function registers are available in 8051 microcontroller. They are IE, interrupt enable register, interrupt priority register, PCON, power control register, SBUF, serial buffer register, SCON, serial control register, TCON, timer control register, TMOD, timer mode control register, TL naught, timer 0, lower byte, TH naught, timer 0, high byte, TL1, timer 1, low byte, TH1, timer 1, high byte. So these are the special function registers. These are above the internal RAM. So internal RAM is ranging from 00H to 7F. From 80 onwards, the 21 addresses are provided for special function register. That means 8051 is having 21 special function registers. And coming to this ROM. ROM stands for read-only memory, which is normally used to store your application code as well as some constant or permanent data. Okay. So, and this the address range is from 12 zeros to 12 H. But in hexadecimal, the address range is 3 zeros H to 3XH. And the ROM is non-volatile memory. So that's why we will use it for your program as well as some permanent data. So this is about program memory of 8051 microcontroller, which is available internally of 4 kilobytes. Then coming to ports, we are having 4 IO ports. They are named as port 0, port 1, port 2, port 3. Here, if you observe here, the port 0 is having dual function. And one important thing we need to discuss here uh, to understand this ports operation. If the 8051 is utilizing its internal memory, then that is called as standby mode of operation. Suppose in some applications this internal memory is not sufficient. In that case, you need to go for external memory. Why? Because the memories are not sufficient, we need to use external memory. That type of mode is called as extended mode of operation. So based on the standby mode of operation or extended mode of operation, these lines behaves, port 0 lines are behaves as either 8 IO lines or general purpose IO lines, CPIO lines, or they are also used for generating lower order address and data bus. That means it is also acting as a time division multiplex address and data bus. Lower order address and data bus, AD0 to AD7. So this address AD0 to AD7 is used in extended mode of operation. In standby mode, this is directly utilized as general purpose IO. General purpose IO. And here we need to note one important thing here. When you are operating in standby mode, it is general purpose IO. So if you want to use this port line as general purpose IO, you need to connect external pull-off register that should be tied to 5 volts through a 10 kilo ohm resistor. Why? Because the port 0 is a open drain configuration. So whenever you are connecting any input or output devices, this MOS transistor may be damaged. To overcome this problem, normally we will connect it to 5 volts through a pull-up resistor of size 10 kilo ohms. This is one of the important thing we need to note down for port 0. But whereas port 1, port 2, port 3, these three ports are internally having pull-up registers. That means you can directly utilize port 1, port 2, port 3 as general purpose IOs. Okay, this is one of the important point we need to note for port 0 when you are operating in a standalone mode. But in extended mode, it can be used as a time division multiplex address and data bus. And next, coming to port 1, it is having a only single function in both the standby mode and extended mode. It is used as general purpose IO only. General purpose IO means you can connect any input or output devices. And next port line is the port 2, where this is also having dual function. In standalone mode, it is acting as a general purpose IO. In case of extended mode, it can carry higher order address bus, that is A8 to A15. And coming to port 3, this is also having separate functions. One is general purpose IO in standalone mode, and in extended mode it is having several functions. That alternate functions we will discuss one by one. So two out of these 8 lines, 2 lines are provided for interrupt. They are INT0 and INT1, and 2 lines are provided for counter operation, timer 0 and T0 and T1 inputs, and 2 inputs are provided for serial data transmission, and 2 inputs are provided for to access external data memory. So these are the alternate functions, total 8 pins. The further we will discuss these pins description in pin diagram. Coming to system timing and control unit, memory control unit. So first, the 8051 microcontroller requires a 5 volt supply, where through VCC you can give the 5 volt DC, and for ground you need to provide 0 volts. These two are power supply pins. In addition to this power supply pins, the 8051 requires timing information. The timing information should be, we will give to the 8051 microcontroller through two crystal oscillator pins, XL1 and XL2. These are the inputs for the 8051 microcontroller. And here we can apply a frequency in between 1 megahertz to 40 megahertz based on our requirement when you are operating parallel communication, but parallel data transmissions. But when you are operating with serial data communication, so when you are using a serial port if of 8051, so in this case you need to supply here 11.0592 megahertz only. So how much we need to supply here? 11.0592 megahertz only when you are operating in a serial communication mode. Okay, so these are the crystal inputs, and further we will discuss what is the oscillator we are used. There are two different types of oscillators we will use. One is crystal oscillator, another one is the normal oscillator. So the structure we will discuss in the while discussing in the pin diagram. Then we need to discuss these three control pins here. Let us see EA bar. So EA bar is the stands for, it is active low input, active low input, and EA stands for external access. So that means if EA bar is equal to 0, is nothing but the 8051 microcontroller not using internal program memory. It is not using internal program memory. It is completely using external 64 kilobytes of memory. That is nothing but, that is ranging from 00H to FFFH. External program memory only, external ROM only. But whenever you are supplied logic 1, instead of 0, if you supply logic 1 here, in that case, first it will utilize this memory, then only it will access the external memory from 1000H to FFH. That means it first utilize the memory 00000H to triple FH from internal memory, and then next address will be fetched from 1000H. So this is the use of EA bar. EA bar specifies either the 8051 microcontroller is utilizing complete external memory or internal plus external memory. Okay. Then coming to next control pin, ALE. ALE stands for address latch enable, which is used to demultiplex this time division multiplex address and data bus available at port 0. Available at port 0. What is the function of ALE? ALE stands for address latch enable, which is used to demultiplex this time division multiplex address and data bus. How it will demultiplex? It is a output signal, active high output signal, so which will specify AD0 to AD7 lines are having address information when ALE is equal to 1. When ALE is equal to 1, it is having a address. If ALE is equal to 0, which specifies data, that means D0 to D7 is available on these lines. So in this way it will specify the demultiplex the address and data bus. And one more line is also available here, PSEN bar. So this PSEN bar is used to, first PSEN bar is nothing but program store enable. Program store enable. Program store enable. So this program store enable is used to enable the external program memory. So here suppose already we know that in extended mode we can interface external memory of program memory of 64 kilobytes. External memory of 64 kilobytes. So when you are operating with 64 kilobytes of memory, you need to enable, you require one control signal. That is nothing but you can read the data from external program memory. That means the PACN bar is directly connected to this RD bar of external program memory. So that's why the name itself, PSEN bar is nothing but program store enable. So to access external program memory, this signal is used. That means whenever this is equal to 0, so the 8051 provides 0 on this PSEN bar. So the 8051 is reading the data from external program memory. Similarly, here we can also discuss these two pins, RD bar and write bar. So if you observe here, already we know that the 8051 supports program memory as well as data memory. So already you know that this program memory is accessed through PSEN bar. That means the PSEN bar is connected to RD bar of 64 kilobytes of RAM, external RAM. Similarly, we are also having, as per Harvard architecture, the 8051 also supports 64 kilobytes of RAM. That is nothing but data memory. So this data memory is nothing but we can read the data, we can write the data. That means it requires two control signals. These two control signals are connected to write bar pin of the 8051 and read bar pin of the 8051 microcontroller. Suppose the 8051 microcontroller need to read the data from external data memory, then it will assert logic 0 on RD bar. So whenever it assert logic 0 on RD bar is nothing but the 8051 microcontroller is reading the data from external data memory. And similarly, when it is reading the data, so the write bar signal is equal to 1 here. But in case of write operation, this will become 0 and this will become 1 now. Whenever this is equal to 1 and this is equal to 0, the 8051 microcontroller is writing the information onto 8-bit information onto external data memory. So that means these two signals are provided to access the external data memory, that is RAM, but this PSEN bar is used to access the external ROM, external program memory. These two are used whenever this internal memory is not sufficient. This internal memory is not sufficient. Okay. Then from this I conclude that the 8051 microcontroller, internal logic diagram is completed, and just we will revise once. It is having a arithmetic logic unit, which is performing the arithmetic and logical operations, and it is also having a register, which is used as a source and destination operand. Most of the time the results are stored in the A register only. That's why it is called as accumulator. And B register is a temporary storage register. It is also used to hold the 8-bit data. PC is nothing but a program counter, which is used to point the address of the next instruction. So it is always a 16-bit register. DPTR is a data pointer, which is also a 16-bit register. And the program status word is used to store the status information of the processor. RAM, 128 bytes of RAM is available, and this is used to store data of your program or application. RAM is used to store your application code as well as permanent data. There are 4 ports are available. Each are behaves as a different way based on its mode of operation. Standalone mode as well as extended mode of operation. And the system timing and control unit provides the required timing information as well as power to the and some control signals to the required operation. So this is the architecture of 8051 microcontroller. Thank you one and all. Now let us see the summary of this lecture. In this lecture, we discussed the internal structure of 8051 microcontroller. Then we covered key components like central processing unit of 8051 microcontroller, RAM, ROM operation, IO ports, but this timer serial communication interrupts we will discuss in further lectures. And next class we will dive into the pin diagram of 8051 microcontroller, where you will learn about the pin functions, configuration, and role in interfacing with external devices. Okay, thank you one and all.